A local bakery sells cupcakes and cookies. The number of cupcakes sold each day can be modeled by this function, is cupcakes. Okay, where X is the number of hours the bakery is open. The number of cookies sold each day is modeled by this other function. Okay, cookies is this other one. Find the function that represents the total number of cupcakes and cookies in X hours. Okay, in our own words, what do we think we have to do? Hashtag. Any idea? Find the, what was it? Find the total. Not solution. It's not asking us to solve anything. Find the total. Yeah, it just literally says find the total cupcakes and cookies. Hashtag find the total. How do you think we're going to find the total? Like if I said I have 15 cookies and 13 cupcakes, how would we find the total? We would add them, yes. That's the same thing we need to do here. We need to add them, except ours are just functions. But you can still add them. Okay, so I need to add C of X plus K of X. So adding those two together, I'm going to write the right part of the function out. So cookies, or I guess cupcakes, was 3x plus 5 plus, and then the cookies one was 2x squared minus 4. Okay. When you add two, these are little binomials. When you add two binomials, does anyone remember if the parentheses are actually doing anything when you're adding? Is it important to have the parentheses? No. We're really going to drop these parentheses and combine some like terms. So I'm going to ignore the parentheses in here. Does the 2x squared have any like terms with it? Nope, so I'm just going to bring it down. Does the 3x have any like terms? No, bring it down. But we do have a couple that have like terms. Those are the constants have like terms. The 5 plus negative 4 would combine to 1. There it is. We added two functions. C of X plus K of X. That function represents the total number of cookies and cupcakes. On the next section, we do have, we're given two different functions. We're given F and G. So we just need to make sure we pay attention to which one we're using first. So the first thing I have to do is f of x minus g of x. So we'll have the f of x function, which is 3x plus 4 over 2. 3x plus 4 over 2. And we're subtracting g of x, which is 2x plus 1. When you're subtracting, are the parentheses important? Yeah, you can't just drop the parentheses and move on. This one also has a denominator, a fraction. If you remember way back from middle school math, in order to add two fractions, you need to have a common denominator. It's the same thing here. We're going to need to have a common denominator. So I'm going to take this 2x plus 1 and I'm going to put it over the same denominator. But if I put a 2 on the bottom, what do I need to also multiply the top by?
2.
Also by 2, right. So I'm going to take that and do the top by 2. And then I'll rewrite my problem. The first one still says 3x plus 4 over 2. The second one, I'm going to take that 2 and distribute it. I'm not going to worry about the negative yet. I'll get the negative in just a second. So I'm going to take 2 and multiply it in, giving me a numerator now of 4x plus 2. If I take that 2 and distribute it over 2. Okay. And then if you remember back from Algebra 1, when you have a subtraction in the middle, that negative needs to go to both the first and second term. So we're going to need to distribute it to both the 4x and the 2. When you're adding and subtracting fractions, do you add the denominators? Go back to like 5th grade brain. Do you add? Thumbs up if you think you add the denominators. Thumbs down if you think you don't add the denominators when you're adding and subtracting fraction. Do you add them or not? Do you add them or not? You don't add them. You just keep it the same, right? So, but we do need to add the numerators here. So I know my denominator is going to stay the same. And then I'm going to add my two numerators together. So I'm going to have 3x plus 4. And then this negative is going to go to the 4x. Negative times 4x is negative 4x. And negative times 2 is negative 2. And then we do have a couple of like terms on that numerator, so I'm going to go ahead and add them together. The 3x minus 4x would become negative x. And then the 4 minus 2 becomes a positive 2. And then denominator still stays the same. You can simplify this one a little bit more if you want to. You can split it up into 2 fractions and write negative x over 2, and then 2 over 2 would simplify to 1. I'm just going to keep it like this. We've talked about how to simplify it if needed. There's our f of x minus g of x. What's different about the second one? That they have numbers, yes. Which we actually the other day, what was that, yesterday? No, first lesson. We talked about how to evaluate a function for a given value. So first thing we're going to need to do is evaluate both functions for the value that we're given. So we need to find both f of 4 and we need to find g of negative 3. So for f of 4, we're going to take 4 and plug it in for the variable on which function? F or g? F, yeah. So we'll take 4, plug it into the f function in place of its variable. That would become 3 times 4 plus 4 over 2. And then if you simplify the numerator, 3 times 4 plus 4 would become 12 plus 4, 16. So that's 16 over 2. And what's 16 over 2? 8. All right, there's f of 4 is 8. And then we'll do g of negative 3. Just be careful, make sure you're using the g function and not the f function. So we'll take this negative 3 and plug it in for what? X. Very good. So 2 times negative 3 plus 1. 2 times negative 3 is negative 6, and negative 6 plus 1 is very good. All right, now that we have the two values, we have f of 4 is 8, g of negative 3 is 5, what's the last thing you think we need to do? Add them, right. The function literally said do f of 4 and add it to g of negative 3. We got to add them together. So f of 4 was 8. Plus g of negative 3 is negative 5. 8 plus negative 5 is 3. Alright, for the third one is multiplying. I'm going to set it up for you and then I'll have you put your final answer on a whiteboard, but let's set it up first and talk about it. F of x times g of x. So we're going to have 3x plus 4 over 2 times 2x plus 1. Do we need a common denominator for multiplying? No, we don't. Anyone remember how we multiply? Can we talk about it in our groups real quick? Let's take 30 seconds, quick table talk. How do we multiply two fractions together? Or how are we going to multiply these two fractions together? Yes, it is top times top, bottom times bottom. Multiply your numerators, multiply your two denominators. Let's do it. I'm going to give you, you think we can get it done in a minute or 2 minutes? 2 minutes. I'm going to give you 2 minutes to do it, and then final answer is going to go on a whiteboard. 2 minutes to do it, final answer on a whiteboard, or you can just do it on the whiteboard. Everybody, oh, we're missing one person. Ariana, who didn't come to school today? Caitlin. Okay. We'll see. She got 1 minute to show up or she absent. We talked about foiling the other day. Let's hope that's still in our brain, how to foil. Put an energy drink in there. That's not right, drink it. It doesn't look like you foiled here. have to FOIL. We have 2 terms on the first one and 2 terms on the second one, so you gotta FOIL. There's no other way to multiply them. Not cross multiply. Alright, throw that final answer on your whiteboard. Good thing I gave 2 minutes. Three, two, one. Boards up. Alright, we're seeing 90% right answers. Good, 90% right answers. You missed something on yours. You're just missing a little somethings in 2 places. Alright, correct answer would have been 6x squared plus 11x plus 4 over 2. If you wanted to simplify it, you could. You can simplify one term at a time. You would have got 3x squared plus 5.5x over 2. Remember, to FOIL, you're going to have to do first term times first term. That's 6x squared. Outer term times outer term. That's 3x. Inner terms, that would be 8x. Last term times last term would be 4. And then bottom times bottom would just be 2. And then you would end up combining those 2 middle terms to get that 11. Refresher of FOIL. Everybody refreshed on it now? Alright, next section. You can also evaluate functions when those functions are in a table format. We can see that here. This is in a table format. There are 2 different tables, one for F and one for G. Just make sure you pay attention to which one is which one. We have the X values and then the F of X, the Y values that correspond to the F function. And then for the second one, we have X values and then G values. So a totally different function. So we're asked on this one to find F of 3 divided by G of 3. So for F of 3, that means we're going to look on the F table for an X value, because remember the inside is still an X value, for an X value of 3 and then write its Y value. I'm going to highlight where it is, or I guess I'll circle it in pink. So we're looking on our table for an X value of 3. It's right here. We need to write the corresponding Y value. So what am I going to write on the numerator? Equals, what's my Y value? 5. Okay. Okay, similar for the bottom, but the bottom uses the G function, G of 3. So we're looking in the G table for an X value of 3. So here's my G table. Here's an X value of 3. I'm going to circle that whole point, 3, 4, which means the output from G of 3 is 4. And you can leave it just like that. You don't have to turn it to a decimal. You can leave it as 5/4. Doesn't reduce, perfectly fine answer. On your whiteboard, using this same set of tables, I want you to find G of 4 minus F of 5. G of 4 minus F of 5 on your whiteboard, and then hold it up. Let's take a minute. I think these are pretty easy. G of 4, use the G table. F of 5, use the F table. Then subtract. G of 4 minus F of 5 on our whiteboard. Garrett, you already got it? That's quick. Oh no, I just realized Alan Silver is going to be really jazzed about this question later today. He hasn't gotten over it yet. Good, good. We finding answers. Good. If you're stuck, talk to a neighbor. Hey, what are you looking at? How are we finding this again? All right, 5 seconds and the board's up. 4, 3, 2, 1. Board's up. Beautiful. Everybody got that right. Yes. G of 4, you just look for the input of 4, is 6. Minus F of 5, so you look for an input of 5, that's 7. Is negative 1. Pretty easy. I love it when they give a table. I think they're super easy. All right. The next table is weird. Okay, it is still a table, but it's not two separate tables. It's two tables combined into one table. They both have the same x's. Okay, the x's are the same, 1, 2, 3, 4, 5. But the f function is this first column. All of these are the outputs for these input x's. The second one is the g function. Okay. Second column, or I guess that would be last column. So this table is different. I'm going to have you guys do this one by yourself. We'll just do an ink pair share on this one, meaning you write the answer and then in a minute I'll just have you share with a partner. You don't have to put it on a whiteboard. Let's take a minute. Let's find that answer of f of 4 minus g of 1 using this combo table, combination table. Again, don't have to put it on a whiteboard. We're just going to pair up and share with a partner. All right, let's have pink share with yellows, purple share with greens. Pink share with yellows, purple share with greens. If you're an odd man out, you'll just have to share after the fact. Pink find a yellow, purple find a green.
I also got -3. So 4f is 2, and g1
All right, if we look at it, for f of 4, remember we're looking for an x value of 4, and what is the corresponding f? So that would be this one right here. If I plug in 4 for x, why did I write 4 again? I should have written x. That's the x value. Come on, brain, you have one job. Okay, so here's our x value of 4. The corresponding f value was 2 minus g of 1. Again, the inside value is the x, so you're looking in the x column for a 1, but you're then looking over at the g column. That would be a 5. 2 minus 5 is -3. Easy? I love a table question. All right, you can also do function operations with graphs. Flip it over. Okay, so we have two different graphs here. Can you tell which one is F, which one is G? They just barely label it. I'm going to highlight it. It's in the top right of each one. This is the F graph on the left side. On the right-hand side is the G graph. There it is. I'm going to do the first one for you just in case, because it is a little bit different than when you have it on a table. For f of -2, again, both of those numbers inside represent the x values. This is an x value. So for f of -2, I'm going to look on the f graph for a point that has an x value of -2. So I'm going to go over here, x of -2. I'm going to go find that point. That's this point. That's the point, -2, 1. And I'm going to write just the output for that point, so just the y value for that point. So f of -2 is, I'm going to write down a 1, and then I'm going to put my plus sign. Okay, and then the second one is g of -3, so I'm going to go over to the g graph, that's the one on the right, and I'm going to look again for a point that has an x value of -3. So I'm going to go look to -3, follow it down to where that point is. That's this point. What ordered pair is that? -3, comma, -2, very good. Okay. And when I write down my value here, I just want to write down the y value that corresponded to the x value of -3. So I'm just going to write down -2. And then at the very end, we're going to add them. 1 plus -2 is -1. All right, next one is multiplying. Just be aware of that. F of 1 times g of -3. I'm going to give you about a minute, and then we'll do an ink pair share and share with a friend. 1 minute, and then share with a friend. F of 1 times g of -3. behind you. You can pick your own favorite. And let's share the answer that we got for this one. Find a friend and share.
I got
Oh my gosh. Alright. F of 1. What'd y'all give for F of 1? -2. We can see that right here. F of 1 is this point right here at -2 times G of -3 again. We already found G of -3. It was also -2. And negative times a negative is a positive. Alright, scooting it over. Function G is a linear function, graphed above. It's this one on the graph here. Function G is a linear function. We've graphed it right here. Y'all remember the old y equals mx plus b, little slope-intercept form? Yeah, okay. Function F is this guy. They give you function F. They didn't graph it. It is a quadratic, but it's not graphed. And we're asked to find the value of f of -3 minus g of -3. F of -3 minus g of -3. F of -3 is going to be pretty easy. We can just plug that in, right? We have the equation. G of -3, can I see that point on my graph if I plug in -3 for x? Can I see it? No. Let's talk to our table. How are we going to do that? How are we going to find G of -3 if it's not on the graph? Don't have to do it yet. You're just talking to your table. How are you going to do it? How will you find G of -3 if it's not on the graph? Okay. Yeah. All right. Best answer I heard. You can find the equation, the function of this. Do y'all remember how to find slope and y-intercept and put it together in an equation? Then we can do that. And once we have that, then we have an equation that we can plug into. Let's write it down. G of x equals, and then we'll find our slope, mx plus b. Okay. Do y'all remember whether m was slope or m is b, or m is y-intercept? M is slope. How do we find slope when we have a graph line? Rise over run. Yes. Rise over run. So you gotta find any 2 points and just count the rise over run between them. So like that's a good point. Like that's a good point. What would be the rise over run to get from 1 to the next? 2 over 1. And a 2 over 1 slope would be the same as 2. Can you see the y-intercept on the graph, or do we need to calculate it? I can see it on the graph. Sometimes you gotta calculate it, and that's really annoying, but I can see it. This is my b. So I'm going to put those together in my equation. G of x equals, my m is 2, so that would be 2x. My b was -1 minus 1. And then once you have that, it should be pretty easy to answer the question, because now we can find f of 3 minus, and then we have our g function to do this one. I'm going to have you guys do this one and put your final answer on a whiteboard. Feel free to work with your table if needed, but final answer is going to go on a whiteboard. Let's take a minute. Final answer on a whiteboard. Bless you. All right, 5 seconds. Get that final answer ready. Throw that marker away. Don't put it back in there. Throw the marker. we go. Boards up. Beautiful, beautiful. So many 17s. Yes, it was 17. We got f of -3 was 10. G of -3 was -7. And 10 minus -7 was that positive 17. Good job. Alright, last one's a doozy. Anyone working ahead and get to that and go, excuse me, what? Excuse me, what? The whole entire question is technically a calculus question. But we can answer this calculus question using Algebra 2 skills. I promise. Okay? It's a 3-part question. It says, using this function, we want to find all of this. F of x plus h plus f of x, and then we want to divide it by h. That's 3 things we got to do. I'm going to have us do them one at a time. Step 1. Find f of x plus h. The other day when we were learning about evaluating functions, we said that whatever is inside the parentheses is what we're going to plug in for what? Plug in for x. And that's what we're going to do. We're going to take this and we're going to plug it in for both of these x's in this function f. So when I do that, in place of the first x, it'll say x plus h squared. And then the second one, we'll just say x plus h. And then we'll have minus 4. We do need to simplify this a little bit. When you see this parenthesis right here, what do we need to do to simplify that? We gotta FOIL that. Yes, we have to FOIL it. Which means x plus h times another x plus h. I'm just doing this on the side of my paper. So if I did first times first, that would be x squared. Outer times outer, x times h is just xh. Inner times inner, h times x is also xh, so another xh. And then h times h would be h squared, right? And then we have a couple of like terms. The two in the middle are both xh's, so you can actually add them together. Anyone know what they turn into when you add them together? 2xh's. X squared plus 2xh plus h squared. Alright, this is my step 1. Actually, no, that's not my full step 1 yet. I'm going to transfer it over here. We got x squared plus 2xh plus h squared. If this is adding, do I really need to keep this parenthesis around the x plus h? No. Plus x plus h minus 4. Now looking through that, do I have any like terms? No, we don't. Okay. That's my full step 1 then. We found f of x plus h. Your step 2 is to add f of x. Do f of x plus h plus f of x. Step 2, we're going to take that f of x plus h and add f of x. Where the heck is f of x? Where am I going to find that? It's right there. That's what we're adding to it. So we're going to take the answer that we just got and we're going to add x squared plus x minus 4. So answer that I just got plus, and then here's my f of x over here. X squared plus x minus 4. All of this is my f of x. Now do we have any like terms that we can combine? Yes. Which ones? We got some x squared plus x squared would become 2x squared. Anything else? The x's. X plus this x becomes 2x. Anything else? The minus 4. What's minus 4 minus 4? Negative 8. What am I going to do with everything else? What do I do with this 2xh, this h squared, and this h? Bring it down. Yeah, just add it to your answer. So we're going to bring this down, and this down, and this down. Plus 2xh plus h squared plus h. We're almost there. That's step 2. What's step 3? Divide by h. Step 3, divide by h. So I'm going to take everybody I got here and Divide by h. Some of them are going to simplify and some of them are not going to simplify. Does 2x squared over h simplify? Mm-mm. What about 2x over h? No. What about negative 8 over h? No. What about 2xh over h? Yes. What's going to simplify? The h's cancel, and we're left with just 2x. What about h squared over h? Just h, right? Because you have 2 h's on the top, 1 on the bottom, so you're going to cancel 1 from each place, and you're left with just 1. Most common mistake happens on this very last one. Guess what a lot of people like to do? Will you wake him up? Head up. Head all the way up. Thank you. Good. No, don't even prop it. Don't prop it. Okay. Okay. Most common mistake happens right here. Which h over h? 1. Guess what the most common mistake is? People just cross it out. Yeah, they go, and they don't write the final answer. There you go. Look at y'all. Y'all did calculus. Does that feel good? No. Okay. It is officially time for you to do your 1 DOL of the day.